to invite Mr. Romain Douib, CEO of FMTP Power Sweden. Let us see where he takes us in this storyline.
Thank you very much. I'm very pleased to be here and to meet a lot of people speaking about smart grid. This is very interesting topics. I will be talking about paradigm shift also, as we discussed, heard just a few moments ago. But mainly on a part that is on the commissioning and the maintenance of substations. We can build very good smart grid networks. We can build a very big system, a nice system, but this needs to be tested when we commission them, and this needs to be maintained also. I will just to touch and give some thoughts about those topics. As we know, we had a visible world, analog world in the past, and still today, but to be replaced. And the world was simpler. It was hierarchical, from production down to the distribution. In nowadays, with a smart grid, we are much more interaction. Everything is digital, everything is smart and distributed. So this requires a new mindset in developing tools, but also in developing solutions to maintain the system live. And this is what I would like to talk about. I would like to talk about 61850, which is the standard for communication within smart grid. And this is involved in taking in account SCADA MMS, communication from the station to the control center. And then within the station, we have the Goose protocol, and we have the sampled value protocols coming up. So, and the beauty with 61850, it's accepted around the world, started from the US standard and developed into a common standard for most of the world. So everywhere we go in the world, 6150 is the communication protocols for smart grid. So the content of my topics, I'll try to be short. Content of my topics will be to show that there is a useful built-in supervision mechanism into those protocols. We will look at comparison mechanism, use of post-event analysis, and how we do accurate and cyber secure analysis. First of all, commissioning, what is it? Is it to make the system working? What is maintenance? This is to verify that this system is still working. And this is simple words, but in fact, in theory, when we have a data network today, we cannot use the same tools as we had in the past. This is a structure, simplified structure of a station. We have a so-called station bus, and this is on the station bus we have mainly Goose communication or some of the SCADA MMS also. And coming up more and more the process bus, and with merging units for the standard voltage and current transformer. But nowadays we have direct digital voltage and current transformers coming up also. So we are talking about sampled values and Goose in my presentation. These protocols are a quality string, and a quality string built-in, so you have the message, the content of the message, and attached to that message you have the quality string. Very useful information that can mention that if there is a failure, is a communication failure, if there is a bad reference from the source, if there is an inconsistency in the message, or if it's all data. So all this information is flagged into each of the messages that are broadcast. And this is very useful to just to detect and to troubleshoot. We can also, by supervision, graphically show that Here we have a goose with a frequency, 50 Hertz frequency, and we can see that when there is something wrong going on, the quality, the black line, which is correct when it's black, get in different colors depending on the different errors that are accessible from the quality string. So another mechanism that is important also in this, it is the repetition of information and the supervision of that repetition. If this is repetitive signal, if the signal is not coming up after a max certain time, there is an alarm going on. So we can see if the connection is still, if the protocol is still connected and the message pass through all the time. So this can be also monitored in a way that we can see is something called a ghost goose may happen. So it was available and then it disappeared. So it's so-called the ghost goose, and this warning can be very easily detected. Now, there is another easy comparison. It's all the relay in the station have settings. And there is tools today, software tools today, that database that can archive those settings. So those tools allow to compare the content of the relays and the asset management database. So very useful information to detect if there is failure. And as many of the blackouts we have heard the past 10, 20 years due to the failure of the settings when we restart the station. It was not correct settings in the relays. Another comparison that is useful is comparing the goose broadcast, which is in green in my screen here, with the so-called SCL file. The station documentation today is not a binder anymore, it's not a schematics, it is a SCL file, XML file that declare all the different relays and assets and settings. And by comparing this file with the actual scanning of the network, it's very easy to see if there is relays that are active or non-active, or if there is change in the settings or not. So consistency checks are easy to implement. The same thing can be done between two broadcasts. One broadcast made a year ago and the broadcast made this year. We can just compare and see the differences, and the difference will be pinpointed, and then it's easy to troubleshoot and repair and solve this problem. Another aspect also that is more and more demanded is the analysis of post-event. When we have a failure occurring or any kind of disruption of the network, by recording the pre-event and the post-event, we can quite easily analyze what is the source of the that has created this trip of the relay of the breaker, for example. And last but not least, cybersecurity. Taking a computer today with a software and connecting to the stations, station bus is not in many countries and many utilities is not allowed anymore. We cannot rely on the PC and on the behavior of the operating system of the PC. So what we need is a tool that can be secure, so we are sure that it is not injecting anything on the network, not disturbing, not slowing down the system, but also that it's time synchronized. All the elements in the station are time synchronized through the GPS, and now we are synchronizing at microsecond level, so any PC can never reach those levels. So the tool needs to be adapted to the constraint of the new protocols. So takeaways from my presentation: we have to use dedicated, secure tool. PCs are not anymore, and never been, but not secure to be connected. And I meet many utilities that are banned their PC or blocked the ports, USB and Internet port for their employees. There is a built-in mechanism in the protocol itself. We just looked at that, the quality string and the repetition. Very useful tool to debug, to help to debug. And then the comparison mechanism that we went through. And once again, everything is time synchronized. The networks and the amount of data on the network are huge and get bigger for every day. So the time synchronization and analysis of time propagation is really important for the future. Thank you very much.
Thank you very much.